So good afternoon, all. We are going to start the session week 3 by microsensor implantable devices and rodent surgeries for biomedical application. This is a problem-solving session. I'm Arpita Biswas, a PhD scholar from MIT Jaipur in electrical engineering department. So this is more details about me. So in this session, we are going to solve some uh, MCQ questions. So this is the question number one. Hello, am I? You can unmute yourself and please try to keep the answer. Okay. So this is the first question. Identify the correct flow of BCI experimentations. So first option is the stimuli generation, then biopotential and trigger acquisition, then system design, and third is the response extraction and interpretation. Second option is the biopotential and triggered acquisition, then system design, then response extraction and interpretation, and then the stimuli generation. And option C is the stimuli generation, biopotential triggered acquisition, then response extraction and interpretations, and next system design. And the fourth option is stimuli generation, response extraction, interpretations, then biopotential and trigger acquisition, and then system design. So go through the question carefully and try to find out the right option. And there is no hurry, you take your time, but at least try. Do you have any idea? The right option is the option A. Stimuli generation, biopotential and trigger acquisition, then system design, then response extraction and interpretation. This is the question number two. Which among the following is the correct pair of anatomical orientation following medical terminology? First is the front anterior, second back posterior, and third is above superior, and fourth is the below inferior. Or option D is all of the above. Okay, Shushmita. And I think one more student is there. What is the right option? Nanda. What is the right option? Yes, the right option is all of the above. So we are moving towards the question number three. Why are stereotaxic instruments used in neuroscience? First is the stereotaxic instruments are used to record the EEG signals in a non-invasive way. Second is the stereotaxic instruments are used to hold the patient's and animals' head and guide the electrode placement. Third is the stereotaxic instruments are used to provide the photic simulation for EEG recording. And fourth is the stereotaxic instrument are used to record the MRI. So please try to find out the right option. Why are stereotaxic instruments used in option B? Okay. Any other students? Nanda, what is the right option? And Srujana. Yes, the right option is option B. Stereotaxic instruments are used to hold patients and animals' head and guide the electrode placement. Okay. So next move toward the question number four. What are the factors limiting the feasibility of CVD in laboratories? So first coming to the question, what is the full form of CVD? Any idea?
Good evening, ma'am. It's
Okay.
a chemical vapor deposition,
Yes, chemical vapor deposition.
and all the options are correct for it. It's toxic, also hazardous and
Uh,
flammable.
can you little bit explain about it? If you have any idea about what is chemical vapor deposition? how we can like do the chemical vapor deposition. A little bit, if you have any idea. Hello, Sushmita.
Ma'am, chemicals are used to spread on the substrate, but
Only chemicals are spreading on the substrate, or some reaction is happen, or something, some temperature is required for this process.
yes, ma'am, I think stepwise it happens.
Yes.
There were some steps.
So, yes, in chemical vapor deposition, it means in the term of CBD, like chemical vapor and then deposition. Like we are taking some chemicals like in powder form or something in gaseous form, and then it evaporate or vaporized form. Then it start to react or it's prepare or produce some new material. Then it deposited somewhere in the sample. Okay. So this is the process. So now coming to the question, what are the factors limiting the feasibility of CBD in laboratories? So first option is gaseous used in CBD are toxic. Second, gaseous used in CBD are hazardous. And third option is gaseous used in CBD are flammable. And last option is all of the above. So which one is the right option?
All four.
Yes, the right option is all of the above. So next coming to the question, question number 5. Which among of the following is not a thin film deposition technique? So first option is the sputtering, then spin coating, third is the chemical vapor deposition, and then photolithography. Okay. Anyone else? What is the right option? Sushmita, can you a little bit explain about the sputtering or spin coating or chemical vapor? I think we have already discussed the chemical vapor deposition or the photolithography. Little bit idea about it?
Ma'am, photolithography is the technique of designing some pattern on the substrate.
Hmm. A pattern transferring process and spin coating. Where it is used, like in a spin coating process, there is a pin which is moving, and we can place the substrate there, and we drop. If there is some liquid sample is there, now then we drop there, and equally it is sprayed on the substrate. And when it is dried, and in that time, it is also a deposition technique. Like the film is is spreading there. Okay. So the what is and what about the sputtering? Any idea about the sputtering process? I think in the previous class, previous two class, I have already discussed the PVD technique and the CVD technique and what type of PVD technique is there, like the sputtering, thermal evaporation, and also the e-beam evaporation system. So sputtering is a PVD technique, physical vapor deposition. So now can you little bit explain how in the sputtering system the deposition is happening? Where is the target? Where is the sample? And how the deposition process is going on? It is hitting something, or it is bombarding some ion, or anything else? Hmm. if there is a closed chamber in the sputtering, if there is a cathode or anode and there is a target is there, okay, and here is a sample where we want to deposit. So in the closed chamber and some environment is also. So here some argon in the present of plasma, some argon bombardment is there. Okay, in the sample. Sorry, in the target. Like if you want to deposit some gold or aluminium something. So here we use the gold's target and some argon bombardment on this gold's target. Okay. And some of the particle in nanometer particle is deposited on the sample and it is the closed chamber and also the control environment. So pressure is controlled, the temperature is also controlled. So in the control environment in the closed chamber, there is the argon bombardment is there, which is on the target, what we want to deposit. Okay. And some of the particle in nanoparticle of this is deposited on the sample where we want to deposit it. Like if we take the silicon dioxide sample, so some gold nanoparticle is deposited there, and some thin film type of layer is there. Okay, so sputtering is a deposition technique. Spin coating, and in spin coating, there is a spin is present, and here we place the sample, and it is moving like it is moving, and here we drop some liquid sample. Okay, drop this liquid sample, and it is spread over the sample, and when it dry out, then it is like behave like a like deposited or spreading a layer like thin film. Okay, so spin coating is also a process, and then the chemical vapor deposition. Yes, of course, using the chemical vapor deposition, we can deposit a thin film. So photolithography is a pattern transferring process. I have already told in the last class that if there is a mask and some pattern is there, like some gate or source and drain is there, in that case, from mask to the sample, okay, from mask to the sample, we can transfer this pattern. Okay, so there's some process like UV exposure, development, and after the development, we go for the etching process. And what about the etching process? Like it's removal some unwanted portion or particle. Okay, then after the etching process, we dry out something like annealing, something is there. So this is the process or part of the photolithography, like a pattern transfer process. So it is not about the thin film deposition. So which one is the right option? Option D is the right option. Okay. So next we move towards the question number 6. Identify the correct statement for the sputtering yield. So first option is a sputtering yield is a ratio of the number of incident atoms to the number of sputtered atom. Second is the sputter yield is directly proportional to the binding energy. Third is the sputtering yield is directly proportional to the square root of the ion energy. And fourth option is the sputtering yield is inversely proportional to the mass of the ion. So there's no hurry. Go through the question carefully and then try to give the right option. Can you little bit explain about it?
Ma'am, sputter yield is the ratio of number of sputtered atoms to number of incident ions. And
Mhm. Which option? Option?
B is the correct answer.
Mhm.
Directly
Um,
proportional to binding and
Here,
sorry. It's
Um,
C. Proportional to
yes,
the square root of ion
option C
energy.
is the right option. Sputtering yield is directly proportional to the square root of the ion
Ion
energy.
energy.
Yes, yes. So now coming to the question number 7. What is a commonly used EEG or ERP marker to determine the brain ability to respond the auditory changes? So MMN or P300 alpha wave or ERN. And I have taken this question directly from the lecture. So I think you have gone through the lecture and find out the right option. Brain ability.
MMN,
Yes, MMN is the
mismatch
right option.
negativity.
Yes, yes. So this is the question number 8. Which is the correct flow for MNN extraction? First is the biopotential and trigger acquisition, then filtering, then event list generation, or epoch generation, or artifact rejection or averaging. Then second is the bipotential trigger acquisition, then event list generation, then epoch generation, artifact rejection, averaging, or then filtering. And third option is the bipotential and trigger acquisition, filtering, epoch generation, rejections, averaging, or event list generation. Our fourth option is bipotential and trigger acquisition, artifact rejection, filtering, event list generation, and epoch generation or averaging. So go through the question carefully and find out the right option. And every week I uploaded this question, like this lecture video in YouTube also, and this PPT also I uploaded. So please go through the question carefully. This type of question will come in your exam also. So multiple number of 35 to 40 number of question per week I have now here we discuss. So I think it will definitely help in your exam also. So please go through the question and all the lecture video. It will clear your concept also.
Ma'am, is it D? Last option.
Can you little bit explain?
Means in the EG, the software we are using, in the
Mm,
artifact rejection, we will be removing the data segments which are due to, example, some eye movement or there,
mm.
and filtering those means the step.
I think one more student is there. Please try to solve the question. Take your time. So right option is option A. Okay. You can cross check also. Biopotential and trigger acquisition, then filtering, then event least generation, then epoch generation, then artifact rejection, then averaging. Okay.
Ma'am, I was studying it, but in the previous question, uh, isn't it
Yes.
should be artifact rejection after biopotential trigger acquisition?
In the lecture, I have seen it is biopotential and trigger acquisition, then filtering, then even list generation, then epoch generation, then artifact rejection, and then averaging. You can also cross check if you have doubt. Okay.
Yes, ma'am.
And this is the question number 9. Which among the following provide the important information about the frequencies embedded in the signal? So first option is the amplitude spectrum, then histogram, then domain waveform, and the scattered plot.
Ma'am, amplitude spectrum.
Yes, amplitude spectrum. Good. And this is the question number 10. Which of the following statement is correct for the time frequency features for epileptic and normal EEG, ECOGs? So first option is the normal EEG and ECOGs have higher amplitude and higher frequency than epileptic EEG and ECOGs. And second option is the epileptic EEG and ECOGs have higher amplitude and higher frequency the normal EEG and ECOGs. And third option is the normal EEG and ECOGs are epileptic. EEG and ECOGs cannot be visually differentiable. And fourth option is normal EEG and ECOGs and epileptic EEG and ECOGs differentiation cannot be automated. So please go through the question carefully and find out the right option.
Ma'am, B should be there. Epileptic EEG should have
Yes,
higher amplitude and higher frequency than
yes.
normal.
Yes, good. So the right option is option B. Sham, do you have any idea about this question? Answer? You can unmute yourself. And this is not it is not mandatory that you are going to give the right answer, but at least you can try. Okay. So the right option is option B. Epileptic EEG and ECOGs have higher amplitude and higher frequency than normal EEG and ECOGs. So this is the question number 11. What is the primary mechanism of material transfer in sputtering? So first option is the thermal evaporation. Second is the ion bombardment. C is the chemical reaction, or D is the electrostatic deposition. And there is no hurry. Take your time. And here also we are going to again discuss about this or what happened in the thermal evaporation, because it is also recall your previous lectures, right? Again and again we are discussing, then it will also you can also practice here your in your previous lectures, and where the argon bombardment take place, where the thermal, what happened in the thermal evaporation, like how the deposition technique took place, and where the chemical reaction has happened, and where the electrostatic deposition is happened. I think in the previous classes and previous lecture, it is already discussed. So this is a very simple question, just for recall your previous lectures. What is the primary mechanism material transfer in sputtering? In the previous, I think in this lecture also I have discussed about the sputtering, but about the sputtering, how it took place. So what is the main funda is there?
Ion bombardment.
Yes, the argon ion bombardment. Yes, good. Like in the closed chamber, Here is a sample, here is a target, and here the argon is bombardment on the target, and some of the particle is deposited. So main funder is the ion bombardment. Okay, so option D is the right option. Good. So this is the question number 12. Which gas is most commonly used in the sputtering process for neural implant? First is the oxygen, second is the argon, third the nitrogen, and fourth is the helium. So what is the right option? Okay, option B. Yes, option B, the argon, right. So we are moving toward the question number 13. Which type of sputtering process enhances the film uniformity and reduces the contamination? First is the DCS sputtering, second is the RF sputtering, third is the magnetron sputtering, and option D is the reactive sputtering. So please go through the question carefully and try to find out the right option. So which process we are getting the more uniformly and which reduces the contamination, like DC, RF, magnetron, or reactive sputtering. You take your time. There's no hurry, but at least try. Mm, record this thing. So what is the right option?
Ma'am, don't remember these different types.
Okay. So the right option is option C, magnetron sputtering. Okay. So next we are moving towards the question number 14. What is the primary advantage of sputtering over the thermal evaporation for neural implant? First is the higher deposition rate. Second, the better adhesion and uniformity. Third is the lower processing temperature. And option D is the less energy consumption. So go through the question carefully and find out the right option. Yes, option B is the right option. Better adhesion and uniformity. Good. This is the question number 15. Which factor does not significantly affect the sputtering efficiency? First is the chamber pressure, second the substrate temperature, third is the target material composition or environmental humidity. So go to the question carefully. Which factor does not significantly affect the sputtering efficiency? Chamber pressure, substrate temperature, target material composition, or environmental humidity.
Ma'am, is it substrate temperature?
No, not substrate temperature. Which factor does not significantly affect. If you are giving some temperature, na, it will affect on the deposition rate or something addition. So it affects. One by one, you can go through the option like chamber pressure. You know that the sputtering is happen in a closed chamber. Of course, the chamber pressure is affects the sputtering efficiency. Okay. Then substrate temperature, yes, substrate temperature also. Then target material composition. Of course, the target material composition affects the sputtering efficiency. And last is the environmental humidity. Environmental humidity, the sputtering is happening in the closed chamber. So the environmental humidity is affecting or not, you say? Closed
It
chamber,
will
the
not affect.
control, yes, in closed chamber, the control environment, the deposition is happening. So in environmental humidity is not going to affect the sputtering efficiency. Okay. So the right option is option D. So next we are moving towards the question number 16. Which of the following is a limitation of sputtering in neural implant fabrication? First is the poor step coverage on complex structure. Second, the high contamination risk. Third is the limited to low melting point material. And fourth is the low adhesion strength. So try to give the right answer. Here we are discussing about the limitation of sputtering. Of course, there is a limitation of sputtering. That's why we go for the another process like in thermal evaporation, some limitation is there. That's why we were moving towards the sputtering. Then sputtering is there is some limitation. Then we can go for the e-beam evaporation. And if there is also there's a limitation, then we can go for the some chemical vapor deposition technique. So here we are discussing about the limitations of the sputtering in neural implant. So first option is the poor state coverage on the complex structures. Second, the high contamination risk. Third is the limited to low melting points materials. And fourth is the low adhesion strength.
Ma'am, coating should be is uniform in sputtering, so option A will be correct, I think.
Yes, option A is the correct option. Four step coverage and complex structures. So next we are moving toward the question number 17. What is the key difference between the PVD and CVD? First is the PVD involves in the chemical reaction while CVD does not. Second is the CVD involves gas phase chemical reactions while PVD is a physically process. And option C is the PVD uses liquid precursor while CVD does not. And in the fourth option, CVD is used only for the organic materials. So which one is the right option?
B.
Yes. But in CVD, not only in gaseous phase chemicals they are used, sometimes like in atmospheric pressure, CVD, actually I'm also use the chemical atmospheric pressure chemical vapor deposition technique. So here we use the precursor in the powder form. Okay, then we heat it up and it is evaporate and then it's react and deposited on the sample. So yes, here the option B is the right option. But not only in the gaseous form, Also, in the powder form, the precursor is present in the CBD. It depends on which technique you are using. Like in LPCBD, you can use the gaseous phase precursor. In atmospheric pressure, chemical vapor deposition, you can use the in the powder form the precursor. And also in there are different type of like plasma enhanced process, the low temperature CBD techniques. Because in the atmospherics or the low pressure, it's required some higher temperature. Okay, but if you go for the plasma enhanced chemical vapor deposition, in that case, we require we can do the reaction in the low temperature. So here the right option is PVD involves in the gas phase chemical reaction, while PVD is a physically process. So next, this is question number 18. Which of the following is not a type of chemical vapor deposition? Like plasma enhanced CVD. Second is the low pressure CVD. Third is the high temperature CVD. Or fourth is the atmospheric pressure CVD.
Ma'am, is it D? Atmospheric pressure?
No, I have already discussed now. In
Yes.
atmospheric pressure CVD, we can use the precursor and in the powder format. Then we give some higher temperature. It will start to evaporate and then it react. And after the reaction, some new material is prepared. Then it deposited on the sample. So atmospheric pressure CVD is present. So it is also the type of chemical vapor deposition technique. Take your time. There is no hurry. So which one is the right option? Like I have discussed about the plasma enhanced, where we require the low temperature, then low pressure, like low pressure is required, also the high temperature is required. Then high temperature CVD and atmospheric. I think I have already told that yes, atmospheric pressure CVD is also present. So option C is the right option, high temperature CVD. Because in CVD, normally the high temperature is required. So nothing the high temperature CVD is there. Okay. So mostly in CBD, the high temperature is required, but in plasma enhanced CBD technique, some low temperature we can do the deposition. Okay, so the right option is option C, the high temperature. So next, move toward the question number 19. Why is plasma enhanced CVD often used for neural implant? First, it allows the lower deposition temperatures. Second, it increases the deposition rate significantly. Third is requires less vacuum. And fourth, it does not involve the gas precursor.
One, it lowers
Yes,
deposition
yes,
temperatures.
yes, good. Next, the question number 20. Which precursor state is commonly used in CVD process? Solid, liquid, gaseous, or plasma? Commonly used in CVD.
Powder form, you were saying solid.
No, actually, commonly used the gaseous, but sometimes it's required in the powder format. Okay, mostly used in gaseous format. So option C is the right option. And then this is the question number 21. What is the primary advantage of CVD for neural implant? High deposition rate, excellent state coverage, and comfortable coating. Third is the low cost processing. And option D is the ability to deposit only metallic films. So which one is the right option? Yes, option B is the right option. Excellent state coverage and conformal coating. And this is the question number 22. Which material is commonly deposited using the CVD for neural implant? First gold, then silicon dioxide, then copper, then aluminum. So which one is the right option?
Gold.
No, not gold.
Dioxide.
Yes, silicon dioxide. Because for gold, copper, aluminum, we can go for the physical vapor deposition, right? So for CBD techniques, we used like this oxide or some like TMDCs, metal sulfide, this type of. Then this is the question number 23. Which factor affects the growth rate in CBD? Precursor concentration, chamber pressure, temperature, or all of the above? Okay, all of the above. Yes, the right option is all of the above. Can you little bit explain about it?
Ma'am, chamber pressure, if it is reduced, it will give better yield,
Hmm.
chamber pressure.
Hmm.
And as you told, temperature also affects the CVD
Hmm.
growth rate.
Hmm.
Uh, and I think precursor concentration is also directly proportional to this. Sorry, this is wrong. Precursor.
Uh, yes, if you're like precursor concentration means how much you are taking the precursor and then you evaporate and then react. Of course, the precursor concentration also affects the growth rate. If you're taking some more material or more concentration, of course, the deposition rate will increase, right? So, right option is all of the above. Then this is the question number 24. Which deposition technique is better suited for coating non-line on side areas in complex implant geometries? So first is the sputtering, then CVD, then electron beam evaporation and thermal evaporation. So which deposition technique is better suited for the coating non-line on site areas? Take your time, there's no hurry. The right option is the option B, the CVT technique. Okay. So next move toward the question number 25. Which process is typically performed at higher temperature? Sputtering, CVD, both operate at the same temperature, neither require high temperature. So which one is the right option?
Screen is not changing. It's showing question 24.
But here, okay, I'm again going to share. Now you can see the slide, or you can again join. Hello. As the question number 25 is visible, Which process is typically performed at higher temperature? Sputtering, CVD, or both, or neither require the high temperature? Ashwin, what is the right option? Let's try to solve the question. So the right option is option B. Okay, the CVD process. So next move toward the question number 26. Which deposition method is generally faster for metal deposition? First is the sputtering process, then CVD, then atomic layer deposition, and then electroplating. So which deposition method is generally faster for metal deposition? So the right option is option A, the sputtering. Next, which process is more energy efficient for large scale neural implant coating? First is the sputtering, then CVD, then both, and neither is efficient. So which one is the right option? Yes, the CVD is the right option. Good. Next question number 28. What is the primary purpose of a stereotactic surgery in rodent? First is the to perform the general surgery on rodent. Second, to precisely target and manipulate specific brain regions. Or C, to implant the large device into the body. And fourth is to study the muscle movements in rodents. So go through the question carefully and try to find out the right option. So please try to find out the right option. Ashwin, what is the right option? Please unmute yourself. The right option is option B, to precisely target and manipulate the specific brain region. Second is next is 29. Which key instrument is used to stereotactic rodent micro neurosurgery? First is the micropipette puller. Second is the stereotactic frame. And third is the centrifuge. And fourth is the ultrasonic skull. So please try to find out the right answer. Yes, the right option is option B, the stereotactic frame. Okay, so this is the question number 30. What is the primary anatomical reference used for positioning in rodent? Stereotactic surgery. Hippocampus and amygdala. Second is the bregma and lambda, and third option is the cerebellum and medulla. And fourth option is the corpus callosum and stratum. So which one is the right option? Yes, option B is the right option. Bregma and lambda. Okay. Next is the question number 31. Why is the stereotactic accuracy important in rodent neurosurgery? First, to minimize the invasiveness and improve the targeting precision. Second, to reduce the surgery duration. Third, to increase the chance of spontaneous recovery. And fourth, to improve the animal mobility. So, which one is the right option?
Ma'am, this technique will be invasive, also stereotactic. It is there.
So which one is the right option?
Ma'am, targeting will be precise, but I think it is invasive also.
Hmm.
Stereotactic surgery.
So it is option A, right? To minimize the invasiveness and improve the targeting precision. So right option is option A. So this is the question number 32. Which type of anesthesia is most commonly used in rodent neurosurgery? First is the isoflurane gas. Second is the lidocaine injections. Then the ether gas and the halogen gas. So which one is the right option? Is there any right answer? Which one is the right option? Yes, the isoflurane gas is the right option. And then next move toward the question number 33. Which tool is commonly used to drill a small hole in the rodent skull during the stereotactic surgery? Bone saw, dental drill, scalpel, or electro cautery device? So, which one is the right option? No, option D is not the right answer. Any other? Which one is the right option? So the right option is option B, the dental drill. Okay. Next, move toward the question number 34. What is the purpose of micro injector in stereotactic surgery? First option to administer anesthesia. Second, to precisely deliver the small volumes or substances into the brain. Third is to hold the rodent head in place. Or option D, to monitor the brain activity. So find out the right option. So which one is the right option? Please find out. So the right option is option B, to precisely deliver the small volume of substances into the brain. Okay, so we are moving toward the question number 35. Which of the following is a common method for confirming accurate electrode or injection placement? So first is the MRI imaging, second is the histological verification, third is the measuring tail movement, and fourth is the observing breathing patterns. So please go through the question carefully and try to find out the right option. No, not the MRI imaging. Please carefully go through the question. The right option is option B, the histological verification. Okay. So next we are moving toward the question number 36. So which of
Ma'am,
the
can you explain
following,
this previous one? And previous.
this question is directly taken from the lecture video. Just a minute.
Okay, ma'am. Okay.
Um, yeah, this one, right? This directly taken from the lecture, that which of the following is commonly method for confirming the accurate electrode or injection placement. So they have given that the histological verification. You can also go through the lecture for cross check. Okay. So this is the question number 36. Which of the following factor does not significantly affect the stereotactic accuracy? Proper calibration of the stereotactic flame. And second option is the precise alignment for Bregma and Lambda. And also third option, the size of the rodent's ears. And option D is the stability of the rodent head. So please try to find out the right option. No, not option C. Just a minute. I think it is cardiac surgery. Which one? Uh, sorry. Sorry. It's 36, right?
Question 36.
Yes, question number 36. The size of the rodent ears. Yes. The right option is option C. Next is the question number 37. Which of the following is not a common application of a stereotactic rodent neurosurgery? So first option is the deep brain stimulation research. Then second is the targeted drug delivery. Third is the cardiac surgery. And fourth option is the optogenetics experiments. So which of the following is the right option?
Ma'am, is it cardiac surgery? C.
Yes, the right option is the cardiac surgery, option C. Good. This is the question number 38. What is the primary concern when the performing surgeries near the brain stem? First is the risk of damaging the vital anatomy, automatic function. Second is increase the risk of injection. Third is difficulty in bone healing. And option D is the high bleeding risk. So which one is the right option?
Ma'am, A.
Yes, risk of damaging vital automatic function. Good. And next is 39, question number. Why is post-operative care important after the stereotactic rodent neurosurgery? First, to ensure the proper healing and reduce the stress-related complications. Second, to check if the rodent wakes up quickly. And third option is to prevent the weight gain in the rodent. And fourth option is to evaluate the muscle development. So which one is the right option?
A, proper
Yes.
healing and reduce
Yes,
stress.
to ensure the proper healing and reduce the stress-related complications. And this is the last question, question number 40. So, which of the following is a potential complication of stereotactic rodent neurosurgery? So, first option is infection at the surgical site, then the brain hemorrhage, and third option is the misplacement of the injections or electrode, and option D is all of the above.
All.
Yes, all good. So now we are ending the session here. Next, we will meet next Tuesday, 7 to 9 p.m. And before coming to the class, please go through the lecture video. Okay.
Yes.
Okay.